Well, hi everyone. Welcome to Unit 5, Lesson 3. Lesson 3 today, we're going to talk about the ASCII system and the binary representation of coding. ASCII, you ask, what is it? Well, ASCII is the American Standard Code for Information Interchange, the universally recognized raw text format that any computer can understand. We use that to decode things. We use it for communication between computer and computer. We use it for communications between us and the computer when we're typing it in. Today, in this lesson, you're going to learn how to use your binary code system for encoding information. The ASCII system will represent letters as well as characters. In the beginning of the lesson, I'll introduce you to the fact that computers must represent information using either on or off. Then you're going to be introduced to the ASCII system representing text and binary symbols. You will practice using the system for encoding your own message and then create something later on to have somebody else encode for you or decode for you. This lesson gives you the opportunity to make some real-world connections from the previous lesson and review some of the concepts you'll see in this activity. The objective: define a Aberrant binary system as one that uses just two possible states to represent information. What does that mean, two possible states? Two possible states are, for instance, on and off. If something is on, you know it's on. A light will show up. Oh, here's an example. I'll give you an example. For instance, I give you a raw wire to hold on to. I have a switch. It's all hooked to a battery. I turn it on. What does that do? It gives you a shock, or at least it should. It tells you it's on. If I throw the switch off, the power is no longer going to that little raw piece of wire that I gave you. You now are not getting shocked, so it's off. Okay, so on or off. That is the two bits of information that a computer reads off of. Now, how they put that together, we're going to talk about right now. The next objective: define a bit as a single piece of binary information. And this last one: use the ASCII system to encode and decode text information in binary. Okay, so go ahead and pull up code.org, Unit 5, Lesson 3, if you haven't done so already. I've also given you in your classwork an activity guide. We will be pulling up that activity guide if you haven't done so already, and we'll be working on that in about 2 or 3 minutes. Okay, so let's look at the vocabulary again real quick. ASCII, American Standard Code for Information Interchange, the universally recognized raw text format that any computer can understand. Binary, a way of representing information using only two options. Okay, and bit, a contraction of binary digit, the single unit of information in a computer typically represented by either a 0 or a 1. Okay, let's go ahead and read the overview. Okay, overview. This lesson introduces a formal binary system for encoding information, the ASCII system for representing letters and other characters. At the beginning of this lesson, we'll introduce you to the fact that computers must represent information using either on or off. We talked about that. Then we're going to be introduced to the ASCII system for representing text using binary symbols, and practice using this system before encoding your own message using ASCII. All right, so go ahead and pull up your activity guide. It should look like this. Okay, in your activity guide, we're going to look at the code first, and then we'll kind of go through and I'll talk about what we're going to do with the code, and I'll give you time to go ahead and complete the activity guide itself. Okay, so the first part, why binary? Okay, in order to input, output, store, and process. Oh, where did that come from? Input, output, storage, and processing. That comes from way back. Information, computers need to represent it first. Engineers used the tools they had at hand, which was wires carrying electricity. It's easy to tell if a wire does or does not have electricity flowing through it. That's what we just talked about. So engineers needed a system based on just two states of electricity or no electricity, or in other words, on and off, or on or off. ASCII, there are a lot of possible binary systems for representing the letters in binary information, but the most popular is called ASCII. You can see the way patterns of on and off represent each letter in the table below. All right, so go ahead and take a look at this. There's a couple things I want you to notice. Number one, each code or each letter is represented by how many symbols? Go ahead and count them out. You should have come up with 7. Each one is represented by 7. And 7 what? We call those bits. Each code, each circle is a bit. That's a bit of code. Okay, so for instance, if we look at A starts out with yellow, black, 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 yellow. So that is the code for the letter A. And you can go all the way down, keep looking at each one of them. Each one is different. And they've also added something else that we did not have anything for lesson 2. They've added a space. So if you look down here, here's the code for the space. So that when your letters run together or your words run together, you can put a space in there so that you separate them. That way, if I'm reading something that you have coded for me, I will know that there's a space in between each word or letter or however you want your space to fall into the actual code that you're making up. So let's take a look at it again. 7 bits make 1 letter each. Okay, and each one of these is different. Okay, so now let's go down to the first part, first challenge. This first challenge is this portion here. In each of the challenges below, the ASCII system has been used to represent a secret message. Very secret. Keep it to yourself. Luckily, you now know the ASCII system, so you're going to be able to decode the message. Each challenge is representing the letters in different ways, though. Okay, so for the first one, it's pretty straightforward. It's represented by the colors. Now, this is one long line of code. So the first thing we need to do is break it up. Now, if you look at what I've done already, I kind of went ahead and I broke it up. First of all, each letter represents 7 bits. 1, 2, 3, 4, 5, 6, 7. So I took an X and marked it up here. That was the only way I could really mark it. I could also take an Expo marker and just put it on here like this. There's 1. Then we go down here, 1, 2, 3, 4, 5, 6, 7. There's 2. 1, 2, 3, 4, 5, 6, 7. There's 3. 1, 2, 3, 4, 5, 6, 7. There's the 4th letter. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Hey, what do you know? It comes out even, which is what it should do. Now, we've broken them up into 7 bits. So now we have to go back and decode it. So for the first one, we're going to look at yellow, 4 blacks, and 2 yellows. So yellow, 4 blacks, and 2 yellows. So yellow, 4 blacks, and 2 yellows. There it is. It's the letter C. So we would go back down here, and we would take it back to right there, and we would say the first one is a C. Well, hard writing on my computer. Anyway, that's a C. So now I want you to go ahead and take a few minutes and do the rest of them and tell me what you come up with. Okay, that should have been enough time. If you came up with CS rocks, you are right on. That's what it means. Now, the first person who thought this up or who came up with the idea wasn't really thinking about how we would interpret this word or this way of coding. C being a C to maybe the start of a word, S being the start of another word, or part of another word. But when you look at it, they're just initials. And CS stands for Computer Science Rocks. So it kind of throws you off in that respect because you're not thinking of it as representing just the letter itself. It just represents the letter as being part of CS Rocks. Now, whether that made sense or not, I hope it did because I tried to explain it the best way I could. So let's go ahead and wipe this off my computer. Okay, so now we're going to go into actual characters. But now see, the characters are represented by also our yellow circle and our black circle. So again, go ahead and count them out. Count out your 7. 1, 2, 3, 4, 5, 6, 7. Okay, we make a mark there and so on. So continue doing that on your own and tell me what this one says. I will give you about 4 or 5 minutes to do that. So go ahead and finish up that. All right, you should be done by now. And if you came up with pizza, you are right on. That is what the cats and the bear represent. I guess that's a bear. Represent is pizza. For challenge 2, the coding came out to be pizza. So let's go ahead and take a look at challenge 3. Challenge 3 is a little bit longer, a little bit tougher. So do the same thing. Go ahead and take it. Count out your 7. Now remember, 7 bits for each letter. So we're still counting out 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And keep going. So go ahead and spend a few minutes on that, and I'll get back to you, and we'll tell you what that means. All right, welcome back. If you came up with, I like to eat, you are correct. You are right on with challenge number 3. I like to eat. A little bit tougher, a little more challenging. So now let's go on to the next one. The very last challenge for you is to create your own. Now, by creating your own, you're going to give it to a family member and have them try and decode it using your binary code from when we first started. So using, you can make your own pictures. You can actually use the colors. You can use an X and a circle if you'd like. So for instance, if I were to create a puzzle, maybe I might use an X and an O, just as an idea for something different, X and an O, and then I might create something for this. Now, remember, we're still talking 7. 1, 2, 3, 4, 5, 6, 7. So this would be my first letter. So I'm going to go up and find out, instead of putting circles, yellows and blacks, I'm going to put an X and an O in that spot and create my own code. So go ahead and create something and come back in a couple minutes or in a few minutes. This will probably take you a few minutes to do that and tell me what you created. All right. All right, welcome back. I hope you came up with a nice little bit of code to give somebody, a family member, and let them decode it for you. Kind of is fun in a way. It kind of comes back to that again, decoding secret information that maybe someone gives you, somebody that you want to pass a message on to somebody, but you two maybe only know the code. This is kind of the same idea here. We are using the binary code, and each one of those is a bit. Okay, so remember that portion of it, because we'll be using that later on in the unit. Okay, so that's pretty much it for lesson 3. Lesson 3, again, dealt with the binary code, ASCII 2, and how we go and encode and decode messages for a computer, for a friend, or for just somebody that you want to pass a message on to. So I hope you enjoyed it, and I look forward to seeing you in lesson 4. Thank you very much.